Functional groups. Basically groups of atoms and bonds which define the functions of hydrocarbons. Yes, they define the function, and that's why they are called functional groups. See, so far we have been talking a lot about compounds made up of just carbon and hydrogen. Now let's add these groups of atoms and bonds which will make them perform some special functions. Okay? For example, I have one group of atoms, C double bond with oxygen, single bond with OH. And this is an empty space where different hydrocarbons can get attached. Okay? So this group of atoms is called carboxylic acid functional group. And it's called acid because, the molecule that it gets attached to will now behave like an acid. When that molecule is mixed with water now, it will release H plus ions. That's how acids are defined, right? Now let me add this group to a hydrocarbon and show you. So first of all, I'll remove a hydrogen, and in place of that, I will add this functional group. Now, if you check experimentally, this new molecule will start behaving like an acid. When mixed in water, this will give off hydrogen plus ions, H plus ions, okay? And this molecule will now have some awesome functions. You can use this in medicine, you can use this in food, you can use this for cleaning purposes. And all of these awesome functions are because of this new group of atoms that got added, not this carbon chain, okay? And if you don't believe me, let me actually add this group to a different carbon chain. Here we have 3 carbons, right? Now I can replace a hydrogen atom with the functional group. Now this molecule also will have similar functions like an acid, just like this one, okay? Now let's do it for another carbon chain. Here I have 4 carbon members. If I replace a hydrogen atom with this functional group, this molecule will also start behaving like an acid and will have similar functions like all of these two. So all these 3 molecules have similar chemical functions, but they have different length of carbon atoms. The only thing common is this group of atoms. So we can say that the common function, the common acidic function is happening because of this group of atoms, right? So whenever this group of atom attaches to any hydrocarbon, it makes it have acidic functions. So in one sense, we can say that this group of atoms, it defines the function of the hydrocarbon, right? And therefore, we call this group of atom a functional group. Now with this, let's look at some other functional groups and their awesome functions that they give. The group of atoms OH, they are called as alcohol functional groups. So this is how they attach with hydrocarbons. And when they do, they give them some special functions. For example, these alcohol molecules, they are all good antiseptics. They kill germs. And they can also be used to dissolve various organic molecules. Now let's look at another functional group, the aldehyde group. Here the group of atoms are C double bond with oxygen, and on one side it is attached with a hydrogen atom. So C double bond OH. Now let me show you how these group of atoms, they attach with our hydrocarbons. Something like this. C double bond OH, and on one side there will be carbon chain, okay? Now when these group of atoms, they attach with hydrocarbons, they give some unique, some special functions to them. That's why they are called functional groups, right? So the special function of aldehydes molecule is that they have a unique flavor, and that's why they can be used in making ice creams or some beverages. Now let's look at another functional group, the ketone group. The group of atoms over here are carbon double bonded with oxygen. And this is pretty similar to aldehyde. They both have a carbon double bonded with oxygen. But the difference is that ketone is open at both ends. At both the ends, we will have carbon chains attaching, okay? Whereas in aldehyde, one side there is a hydrogen atom, and only on the one side we will have carbon chains. So for example, how ketone attaches with hydrocarbons is something like this. See, C double bond O, and on both sides you have carbon chains. On both sides you have carbon chains. If one of these carbon chains were replaced by a hydrogen atom, then we would call this as an aldehyde group, not as a ketone group, okay? And now this has many special functions also, ketones. They are generally used in medicines, okay? Now let's look at another functional group, the carboxylic acid. Well, we have already spoken a lot about them, but what I want to show you is that how similar these functional groups appear. See, all of these 3 functional groups, aldehyde, ketone, and carboxylic acid, they have the C double bond O group in them. Whereas carboxylic acid and alcohol, they both have the OH group in them, right? So they might all appear very similar, but yet they are very different. And they provide very different functions to the hydrocarbons that they get attached to. Okay, one more thing. All of these functional groups are commonly called as oxygen containing functional groups because you can see that all of them have oxygen atom in them, right? Now let's move on. Next, I want to talk about the halo group, the halogen family group. Basically the atoms of chlorine, bromine, iodine, or fluorine. When they get attached to the hydrocarbons, they also impart special functions to them. They will appear something like this. See over here, this is a chloro group attached to the alkane family. This is a bromo group attached to the alkane family. Okay. Now one last group, the double and the triple bond group. Yes, these are also functional groups. When they come in between an alkane, they provide special functions to the alkane. And you might have already seen how they appear in the carbon chain, something like this. So these are also functional groups. So we have seen a lot of functional groups, and these are the broad categories. One is the oxygen containing functional groups, which has alcohol, aldehyde, ketone, and carboxylic acid. The other is the halogen containing functional groups, which include chlorine, bromine, iodine, and fluorine. And the third category is of bonds, double bond and triple bonds. These are also functional groups. Now, one last thing. On the screen, you can see some carbon compounds, and all of them have some functional groups attached to them. And you might also notice that there are some carbon atoms which are missing some hydrogen atoms. For example, this carbon atom can have 3 more hydrogens attached to it. But don't worry about them. I have not written the hydrogen atoms so that we can focus more on the functional groups. Okay? So over here, I want you to pause the video and figure out which functional group is attached to which molecule. For your reference, I have written all the functional groups and their names on the side. So pause the video and try it by yourself first. Now, if you have tried it, let's see. See over here in this one, the first molecule, I see that this is the carbon chain and here OH group is attached to it. And OH group is called the alcohol functional group. So the name of this is going to be alcohol, okay? Over here, I see that this is the carbon chain and this carbon has double bond oxygen and OH. Now, if you look over here, I can see that this functional group is what I notice over here, C double bond O, OH. It doesn't look like arranged in the same order. See, C double bond O, OH on the right, but here OH is on the left, but that doesn't matter, right? So this is the carboxylic acid functional group. Carboxylic acid functional group, okay? Now let's look at this. Here there's a carbon chain. This carbon has double bond O attached to it. And on both sides, it's attached to a carbon atom. So that you can see over here in the ketone. Over here, C double bond O, and both sides are free to be attached with carbon atoms. Not aldehyde. See, aldehyde has one hydrogen atom on one side, okay? So this is going to be ketone. Similarly, over here, if you look, this carbon atom is double bonded with oxygen, and on one side, there is an hydrogen, okay? Only one side it is attached with a carbon. So this is going to be an aldehyde, not a ketone. Now let's look at this one. See, this is strangely written. Here I do not see the structure of the molecule, but I have the molecular formula. But see, I can notice that this part has oxygen in it. So this is going to be the functional group. Now this has 2 oxygens, C double bond, COOH, okay? And there is only one functional group with 2 oxygens, this one, carboxylic acid. So this is going to be our carboxylic acid functional group. Now the last example, in this molecule, this is going to be our functional group because it has oxygen. See, this is the carbon chain and this is our functional group. Now, which functional group is this? Is this the alcohol? Because alcohol has OH and this one also has OH. But see, if alcohol were the functional group, it should be something like this, OH. It should be written as COH. Why is it written as CHO? So yes, you're right. This is not alcohol. This actually is aldehyde. See, aldehyde also has a carbon, oxygen, and hydrogen, right? So to denote this differently, different than alcohol, we write it as CHO, okay? So this is our aldehyde functional group. Now one last question. Out of all of these 6 molecules, which 2 of these will have similar chemical properties? Can you pause and find that out? If you have tried it, let's see. See, compounds which have the same functional groups have the same chemical properties, okay? So over here we can see that this is a carboxylic acid, this has a carboxylic acid, and this one also has a carboxylic acid functional group. So these two will have the same chemical properties, similar chemical properties, okay? And then similarly, we see that this is an aldehyde and this one is also an aldehyde. So these two will also have similar chemical properties. Now let's summarize the video. In this video, we spoke about functional groups, which are basically group of atoms or bonds which define the functions of hydrocarbons. And we also looked at many functional groups and their names.